before we go ahead and further analyze our result and look at SLU7 in more detail, let's do some visualizations to show a summary of the correlation analysis. And one of the best things to do is which a way to show all the data and the distribution is to use a volcano plot. And the volcano plot is basically using the negative log value of the FTR p-value and the correlation coefficient on the x-axis. So this gives us a nice distribution of the data, usually in this V shape, and only the data on the top left and on the top right will be significant. Everything else will be filtered out. And if we have a look how this looks like in our analysis, so if we go further down, I've written the function here. So these are matplotlib functions, relatively straightforward. You can have a look at that. But here is our our volcano plot. So you see a nice distribution. These are our thresholds. So our threshold 0.05 p-value. And we haven't set the threshold for the Pearson correlation coefficient, but we could say anything higher than 0.4 or lower than minus 0.4 would be significant. So here we don't have any significant negative correlations, but oh no, we do have two significant negative correlations, and we have quite a few significant positive correlations. And this here is probably SLU7 and A-trip and things like that. So the most significant ones. So this gives us a nice instant overview. Then we can look at the individual data. So we can see what the SLU7 look like when we plot it against ATR. And here what we want to do is do a scatter plot, but also actually measure the linear regression. So we want to see what would a model look like that would be a perfect line that models this linear relationship between the two. So basically we have to find a line where each dot is closest to the line possible. And there's various methods for that. So, but basically we need these parameters, the weight, which gives us the slope, and the bias, which gives us the value at where x is 0. And the calculating is relatively simple for a two-dimensional data set. But for plotting, what we will do here is we will use a new library, which already does all the statistical analysis for us, and that's seaborn. And I love seaborn. It's a brilliant sort of top-up of matplotlib. It's worth exploring. We're only using it for this linear regression plot, where you basically so if we plot SLU7 against ATR, we're getting a nice model of the linear relationship done for us. We don't need to do anything else. It works as a normal matplotlib, so we can subject it to a normal matplotlib syntax. But then instead of calling, so we're importing it as SNS, import seaborn as SNS, and then we instead of a matplotlib plot, we're using the SNS reg plot, and then we're supplying the x and the y data and then the entire data set. So it will find the ATR and the SLU7 data in here. We have to supply the axis, and then there's different key arguments that give us some aesthetics of the plot that you can explore in detail. I've put a Colab notebook on seaborn for you to explore. It's a really nice library to use, and it generates beautiful plots. So I would recommend you to explore. For our project, the only thing that we will use it for is to show you the linear regression analysis here.